The previous class that we had, we managed to work with the shape, basically, the basics of a quadratic graph, which is a parabola. So in this class, we're going to move on to the roots or the solutions to this graph that we just drew. Remember, we talked about the turning points, line of symmetry. All right. So this is going to be a continuation on the quadratic graph when we are to look into the roots or the solutions to the what? To the graph. So basically, when we are given a quadratic equation, because it's from a quadratic graph, so definitely what you're to solve is a quadratic equation. You think of working with the quadratic formula because that is a quadratic equation, okay? We are having this as our quadratic function, and let's say you're being asked to solve 3 plus 2x minus x squared is equal to 0. It's now an equation. First thing that you think is to use what? The quadratic formula. To apply what? The quadratic formula. But this isn't our case. This is not our case, guys. We are not to use the quadratic formula. We can apply that as a verification or a proof to see if our solutions are in the right direction. If they're actually an estimate. Remember, the graph, it was drawn from freehand. So definitely these roots or solutions will be an estimate. We cannot have exact values as we cannot produce the graph with the same smoothness. So you estimate from what we have, what? From the graph. So the roots, the solutions are obtained what? Graphically. They are obtained graphically. From the graph that we have what? Drawn. So when you are given the function f of x, you have drawn your quadratic graph like this, okay? The roots of this graph that we are given without adjustments, without what? Adjustments. If this is the graph of y is equal to ax squared plus bx plus c, the roots of the function are the ones that we obtain or that we have in the x-axis. That is where the graph intersects with the x-axis. In the x-axis, since that is where y is equal to 0, you are solving the equation when you take this ax squared plus bx plus c to be equal to 0, meaning to say you let y to be equal to 0, which is in the x-axis. So that is why we are focusing on the x-intercepts. So the roots given our f of x is equal to 0. So given f of x is equal to 0, our original function, the roots are the x-intercepts of the given function. So that's the solutions or the roots. The solutions or the roots are the what? The x-intercepts. That is basically what you're going to consider. Where y is equal to what? Where y is equal to 0. From the original graph. But there are other adjustments which can be done if the equation is not what you are given graphically. You are not given that. Okay, let's start with this one first. Okay, let's start with this. We are given this quadratic graph that we drew previously. Then the question can be on the roots or the solutions. They will ask you to solve, use the graph, right? Using what? Using the graph. You'll be asked to solve. They will take this 3 plus 2x minus x squared is equal to 0. This is exactly the function that we were given before, the y that we were given, only that now it is equated to 0. So when this whole function is equal to 0, that is where in the x-axis, like I said before, that is where y is equal to 0, our f of x, the whole graph. So when this graph is equal to 0, that's in the what? X-axis. So where the graph intersects with the x-axis, they do intersect where? At this point and at this point. Those x values are our solutions to the given function. So meaning to say on this one, if we are going to take our x values from this, our x is equal to what? -1. Or x is equal to what? +3. So these are the solutions. X is equal to -1 or +3. Those are the roots or the solutions to that given function. Okay? So this one is direct and straightforward. Direct and straightforward. I want you to see that. If you were given now something like this, solve, they will give you something like 5 plus 2x minus x squared is equal to 0. Want us to be together on this one. So you see that, guys, you have drawn this function 3 plus 2x minus x squared. So do not rush because here you just see there's a 0 there. Okay, these are the roots in the x. No, 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 no. Check properly. Is it exactly the function that you were given before? So we can see that no, this is different. 2x minus x squared. This is exactly what we have, 2x minus x squared. But what about the first value here? This one, 5. This is 5, but here it is what? 3. There is a difference. There is a difference here on the person from the graph function that we're given originally. There's a difference here. This is our graph what? Function. Here, it is what you are given, the question function. All right, this is our question function. Is different, which is different to the graph function. Here, these two guys were exactly the same. What we're being asked, 3 plus, it was exactly your graph function as it is the graph function. Yes, that's why I did not even explain much. So you just take direct in the x-axis. But this one is different. There's a 5 here. Here there's a what? A 3. So how do I solve such type of a question when the question function is different from what I'm given on the graph function? All right, so this is how you simply apply this type. When these two are different, you are going to subtract graph function minus question function. All right, so these are the steps that you're going to take. You subtract the graph function minus what? Question function. What is the graph function? The one originally given on the graph. 3 plus 2x minus x squared is equal to y, which is 0. We are talking about being equal to 0, always equal to 0. Then we are going to subtract the question function, the one that we are given here on the question, 5 plus what? 5 plus 2x minus x squared is equal to 0. We subtract and see what is the difference from here. Quotient minus, the graph, the one that you're given graphic, or the one that you had originally from the information, that table values, minus the one that you are being asked now, the quotient function. So let's subtract 3 minus 5. That's minus 2. All right. So this is what? Minus 2. 2x minus 2x, this one cancels. Minus x squared and minus x squared are the same, they will cancel. So meaning to say, we are going to have a difference of what? Minus 2. And this one's 0. So this one, guys, is the part of y. The 0 there that we're talking about, it is the y. Remember, it was y is equal to y is equal to. So now we are given that y as what? Minus 2. The difference here is the one that you need. This is what our difference. So you are going to draw the line y is equal, because this is y is equal to, so that's a line. This is a straight line. So you're going to draw the straight line. Y is equal to what? Minus 2. I want you to see what's going to happen. Y is equal to minus 2. The question was different from the graph. So you subtract. The difference is the one that you are going to draw. You draw it. All right, let's draw this line of y is equal to what? Minus 2. So it simply passes through the what? The y-axis at what? Minus 2. In the y-axis, this is where we have got what? Our minus 2. All right, so you are going to draw that minus to that line. All right, you're going to draw the line of what? Y is equal to minus 2. This is our line. Y is equal to what? Y is equal to minus 2. Y is equal to minus 2. Okay, so with the line that we have drawn of y is equal to minus 2, that is where we are going to obtain our solutions. Here it simply means our x-axis, the one that we had, is shifted going down. So our graph that we had and the line that we drew of y is equal to minus 2, this will be our new concept of finding solution at the point of intersection. Guys, I hope you're together here. The question that we are given is different from the graph, but the graph is already drawn. So you are not going to redraw another graph for this. No. You do not do that. You do not draw again. You subtract question, the graph minus the question function. The difference is the graph of y is equal to, whether sometimes maybe it was something like this. 3, maybe it was 5 plus x minus x squared. Then when you are subtracting this 3 plus 2x minus x squared, when you are subtracting, you obtain 3 minus 5, that's minus 2, 2x minus x, that's x. All right, I want you to see this is what? This is plus x. This one cancels. So meaning to say this difference is the one that you're going to draw. What is it that you have? Y is equal to minus 2 plus x. That's what? A straight line. We are big there, the use of what? Table of values. If it was like this, you draw that line. Here it was just that it was direct, that after subtracting, we obtained a straight, a straight equation that we can simply represent y is equal to minus 2. It can be back to what you are used to, y is equal to x plus 3. You draw that line, the difference. All right. After you've drawn that from the graph and the line that you've drawn at the point of intersection, that's where your solutions are. So you take these solutions to the x-axis. From here, go straight to the x-axis. From here, straight to the x-axis. So this is the concept. So in our case, we have a horizontal line of what? y is equal to minus 2, this one. So where this line intersects with the original question, with the original function, our graph function, where these two intersect with this curve, they intersect at this point and this point. That is where our solutions are, but we must consider them to the what? To the x-axis. So you have to take these points straight to the x-axis, all right? So you take these points to the x-axis from what you're given. So from here, this one was supposed to be somewhere there at negative 1, comma 5. You take this one straight up to the x-axis. That's negative 1, comma 5 in between. And this one, if we're going to take it straight up, it was supposed to be somewhere here at 3, comma 5. It's only that you see that smoothness, guys, of the graph that we have been talking about before. So if your graph is not smooth, these solutions will be actually difficult now to say, but it's an estimate at the end of the day, so do not worry. So this one was going to be in between minus 1 and 2, that's minus 1, comma 5, 3 and 4, that's 3, comma 5. So these will be our solutions to this equation that you are given on the question function. So our x can be negative 1, comma 5, or x is equal to what? 3, comma 5. So this is what you are going to have. You simply subtract just like that. You take note of what the difference was minus 2. You draw the line of y is equal to minus 2. Okay, let's have another one so that we can properly verify. All right, let's say you're given to solve, still on solving, 1 plus 2x minus x squared is equal to 0. From this graph, then you can see that this is different. We are given 3 plus 2x minus, this was the graph, but our question is totally different. So when it is different from the graph, you have to subtract graph minus question. So our graph function, 3 plus 2x minus x squared. Subtract the question function, 1 plus what? Plus 2x minus x squared. So the difference is the one that you're going to simply draw. 3 minus 1, that's a 2. 2x and 2x cancels, minus x squared minus cancels this one. So the difference is what? 2. So you draw the line of what? Y is equal to 2. That's it. Y is equal to 2. That is horizontally at 2 here. We're going to draw the line. Y is equal to 2. So it passes through the y-axis at what? At the point 2 here. That's y is equal to 2. So y is equal to 2. Then to solve where the original graph and that line of y is equal to 2 intersect, that where these two meet, that is at this point and at this point. So where those 2 points mean the two graphs meet, you use that to obtain what? The solutions. So back to the what? X-axis. As always, your solutions, you take them what? In the x-axis. So you take this point going down to the what? X-axis. So that's somewhere in between there. 1, 2, 3, 4, 5. Negative 0, 0.5 around there, or negative 0.45. You can have something like 0.45. All right. And this one, 2.5 or 2.45, somewhere in between. All right. So you take those values. So yeah, according to my graph here, it's minus 0.5. All right. The x value is what? Minus 0.5, or x is equal to, the other one is 0, 2, this one 2.5. So it's supposed to be somewhere here 2.45 or 2.5. So let's take 2.45 in between. So you estimate according to the graph that you have. So that is how you play around with this type of a question, right? When the two equations are different, graph minus question function, the difference is the one that you are going to work with. So that is the same application, guys, that you're going to use, all right? If it was on this one, all right, they can ask us also the solutions to the given graph. Originally, as it is, if it was to solve using the graph, 2x squared minus 3x is equal to 0. That is from the graph. Originally, this is what we have. Nothing changed from what we are given. Nothing changed. So you just have to take your points direct as they are. So here it's gonna be on the x-axis, that's this point and this one somewhere here. So that's in between, like let's say this is x is equal to 0 or x is equal to this one. It's all right, this is 1 and this is 1,5. 1,5 here. So meaning to say in between 1, all right, like it's gonna be 1,1, 1,2, 1,3, 1,4, somewhere like 1,4, somewhere there, maybe it's 1,45 in between. So you estimate those solutions and also the issue of the scale, guys. Like I said, you must understand your scale. All right, according to the scale, you take those values or points. So that is our x intercept, the solutions to this one. They can make any adjustments. So on the solutions, we are not yet done. We're gonna look into the other aspect, which is where they can actually give you the difference here. All right, take note on this one. You were given a different what? A different equation. Our question was something that was different. So instead of giving us that equation, which is different, they can give us the original, which is our graph function as it is. Solve this 3 plus 2x minus x squared. Then they equate it now. They equate this to any line that they want you to use, all right? Is it y is equal to 2, y is... So let's say they give us this, 3 plus 2x minus x squared is equal to 2. Let's say you're being asked to solve when it is like this. Guys, this is exactly our question function, this one. 3 plus 2x minus x squared, this one. Exactly our question, this one, our graph as it is from the graph. But now they're saying it is equal to 2. So simply say, draw the line of what y is equal to 2. As you had this, separate y is equal to 3 plus 2x minus x squared. They are equal. Y is equal to 2 and that one they are equal. So you're going to draw the line of y is equal to 2, just like what we have here, y is equal to 2. So where it intersects with that graph, you have got your solution. So they could have asked the same question like this, solve this. But instead, they asked in this manner. What happened? They simply took this 2 to the other side. So it was what? 3 minus 2 plus 2x minus x squared is equal to 0. So 3 minus 2 is 1 plus 2x minus x squared. So you see they adjusted that. So if you can also readjust, back it to the original graph that you have and see the difference and have the difference on the other hand like this, if you can do that also, that's actually another way that you can work with to say that I'm given this is 1 plus 2x minus x squared. I'm not supposed to change the meaning of the question. So I'm just going to ask myself what happened, because here it was 3 before. But now it is given as a 1. So you write your original equation. 3 plus 2x minus x squared is equal to what? So what is going to happen here? What happened for us to obtain this 1 here? Before it was a 3, but now it's a 1. So what happened? You can see that it was minus 2, which was what? Subtracted from what? From the 3. So that minus 2, which was subtracted, you take it on the other side. So when you take it on the other side, it will be a positive. So that when you bring it back, it's 3 minus 2, which is what? 1. You are not supposed to change the meaning of the question. You must remain with the question as it was. Do not change the meaning of the question. So this presentation and this presentation is one and the same. So this question here could have been asked in this manner. Solve this equation when it is equal to 2. So we are going to look into that later on. More questions on our solutions, working with exam and so on. But for the basics, this is what you can use. So I want you to use that, answer as many questions as you can. Where you do not understand, let us communicate in the comment section, and also to utilize our community section to send the questions direct that you do not understand. But for now, that is it. Till we meet again.